Is the universe truly infinite? Look up at the night sky. No matter where you are on Earth, when darkness falls and the lights fade, the same question quietly rises. Does the universe ever end? Or does it stretch forever, without edge, without wall, without boundary? For thousands of years, humanity has wrestled with this mystery. Ancient philosophers imagined crystal spheres enclosing the cosmos. Modern physicists use satellites and equations to probe its structure. Yet the question remains, is the universe truly infinite? Tonight, we explore one of the biggest mysteries in science. The first illusion: what we see is not everything. When we talk about the universe, we usually mean everything that exists. But what we actually observe is something smaller, the observable universe. Light travels at a finite speed, about 300,000 kilometers per second. Since the universe is about 13.8 billion years old, we can only see light that has had time to reach us. That creates a cosmic horizon. The observable universe has a diameter of roughly 93 billion light-years, but that does not mean the universe is only 93 billion light-years wide. It simply means that's as far as we can see. Beyond that horizon, we don't know. The universe could extend trillions of light-years further, or infinitely. What does infinite really mean? Infinite doesn't mean extremely large, it means without limit. If the universe is infinite, then no matter how far you travel in any direction, you would never reach an edge. There would be infinite galaxies, infinite stars, infinite planets, and mathematically, possibly infinite versions of you. This sounds like science fiction, but it's a logical consequence of infinity. If space is infinite and matter is distributed somewhat evenly, patterns must eventually repeat. Somewhere, unimaginably far away, there could be another Earth, another Milky Way, another civilization asking the same question. The shape of the universe. To understand whether the universe is infinite, we must examine its geometry. According to Einstein's theory of general relativity, mass and energy curve, space-time, that means the universe can have different shapes, positively curved like a sphere, negatively curved like a saddle, flat. Scientists study the cosmic microwave background radiation, the faint afterglow of the early universe, to measure this curvature. The data suggests something astonishing. The universe appears almost perfectly flat. And here's the key: a perfectly flat universe could be infinite, but there's a catch. We can only measure curvature within the observable universe. If the entire cosmos is vastly larger, it might curve so slightly that we cannot detect it. Just as Earth looks flat when you stand on its surface. So even if the universe seems flat, it could still be finite but enormously large. Finite but unbounded. This idea is difficult to grasp. Imagine living on the surface of a sphere like Earth. If you walk in a straight line long enough, you eventually return to where you started. There's no edge, no wall, no border, yet the surface is finite. The universe could work the same way in 3 dimensions. You could travel forever without hitting a boundary, yet space itself would still be finite. This concept is called finite but unbounded. It sounds paradoxical, but mathematically, it's entirely possible. Cosmic inflation and eternal expansion. Shortly after the Big Bang, the universe experienced a period of extremely rapid expansion called inflation. Some versions of inflation theory suggest something even more dramatic. Inflation might never have fully stopped. In certain regions of space, expansion could still be happening at enormous rates, creating bubble universes. This leads to the concept of the multiverse. Our universe might be just one bubble in a vast cosmic foam. If inflation is eternal, then the number of universes could be infinite. Not just infinite space, but infinite realities. Some with different physical constants. Some where stars never form. Some where physics behaves differently. Infinity becomes layered upon infinity. The philosophical shock of infinity. If the universe is infinite, then statistically, every possible arrangement of matter must exist somewhere. That includes duplicates, not similar versions, exact copies. Somewhere beyond our cosmic horizon, there could be another version of you reading these same words, making the same decisions, believing you are unique, and somewhere else, a version that chose differently. Infinity challenges our sense of identity. Are we special, or are we inevitable? But what if the universe is finite? Let's imagine the opposite. Suppose it is vast but limited. Then a new question arises. What lies beyond its boundary? Is there a wall at the edge of existence? Is there empty nothingness? Physics struggles here. The concept of nothing is more complicated than it sounds. In quantum mechanics, even empty space fluctuates with energy. Virtual particles appear and disappear. True nothingness may not exist. So if the universe has an edge, it might not border nothing. It might curve into something we cannot yet describe. Or the idea of outside might be meaningless, like asking what is north of the North Pole. Time, infinite or limited. Infinity isn't just about space. What about time? The universe had a beginning, at least in our current understanding, about 13.8 billion years ago. But does it have an end? Some models predict heat death. The universe expands forever, stars burn out, and everything becomes cold and dark. Big crunch, expansion reverses, and the universe collapses inward. Big rip, expansion accelerates until even atoms are torn apart. If time extends infinitely into the future, then eventually every possible event, no matter how unlikely, could occur. Given enough time, even the rarest fluctuations become inevitable. Infinity reshapes probability itself, the limits of human knowledge. There is a possibility that we may never know the answer. If the universe extends beyond what light can ever reach us from, then that region is permanently inaccessible. No telescope will ever see it. No probe will ever reach it. We are confined within a cosmic horizon. It's like living inside a vast fog, trying to measure the size of the entire landscape. From within a small clearing, our equations may hint at infinity. Our observations may suggest flatness, but certainty may forever elude us. Why this question matters? At first glance, whether the universe is infinite might seem abstract, but it changes everything. If infinite, nothing is truly unique. Every possibility exists somewhere. Reality is far larger than we can comprehend. If finite, the cosmos is a contained structure. There is a total amount of matter and energy. The universe may have a grand geometric design. Either way, the scale dwarfs human imagination. Yet somehow, within this vastness, consciousness emerged. A small planet orbiting an average star developed life, capable of questioning the nature of the entire cosmos. That may be the most astonishing fact of all. The final reflection. So, is the universe truly infinite? Science does not yet have a definitive answer. Current evidence suggests the universe is either infinite or so enormous that it is effectively indistinguishable from infinite, and perhaps that's the deeper truth. Whether finite or infinite, the universe is vastly larger than anything our ancestors could have imagined, and within that immense structure, we exist briefly aware of it. The cosmos may stretch forever, or it may curve gently back onto itself. But either way, one thing is certain. A part of the universe has become conscious enough to ask whether it has an end, and that might be the most extraordinary mystery of all.